Tanishka, good afternoon beta, good evening beta. Send the link in the group beta and tell everyone to join. Shri Bhavni, I'm fine beta, I'm fine. Beta, send the link in the group and tell everyone to join fast, huh? Okay, we will start the class. In the previous class, just tell beta, inform the group that started class. I cannot stand for long time. Shall we start the class now? Okay, look here beta. So last class we were talking about modern periodic table. In modern periodic table we were discussing about I think we discussed about first periodic table, periodicity we discussed. No, we started with, yes, we finished this one. Yes. Where are the rest of the children here? Can you tell them to join fast? Okay, no problem. I'll start beta. So now look here, we were discussing about, just inform that class started. Only this information you give. I think they are not wanting the class. Now look here. So last class we were discussing about total 18 groups were there. Starting from group 1, we named the group, like specific groups are there, and we started naming it beta from alkali to alkaline. So first group was alkali, then second is alkaline, then third, then 3 to 12 are called as transition element or heavy metals. We call them as heavy metals also. And then pictogens were there, chalcogens were there, and then halogens. So group 16, 17, group 15, 16, 17, we had different names. And then noble gases means noble gas family was there, inert elements were there, and we gave it a specific name. And after that we were discussing about periods and group. So we know that in the electronic configuration, just 1 minute beta. Good afternoon, Kavya. Good afternoon, beta. Nandini, good afternoon. Now look here, we were discussing about elements and groups. In the elements and group part beta. Okay, thank you beta. Yaini, good afternoon. I'm not well still now beta. Don't talk about me. First is your examination. I'm not at all thinking about me right now. My first priority is your examination, board examination. So first we will finish the syllabus, and then I have to conduct examinations also. Lots of work is pending here. Electricity revision, many chapters revision are there, and all the sample papers already came. Xerox given. Everything is ready for test. Coming test. Due to COVID, I just am back by 5 days. So I'm very angry right now. Please kindly cooperate. Inform your friends to be with me right now. I'm very angry right now. So shall we start beta? Now look here, groups and periods. So we know that total 18 groups are there, 7 periods are there. And one very specific thing we are talking about is कि when we discussed about group, we have seen that total 18 groups are there, and it is based on electronic configuration. In a group, the chemical property remains the same for element. In a group, the chemical property remains same for elements, because the reason behind is what is the reason behind that the elements in the group will have same chemical properties. The element in a group will have, good evening Kamya, the element in a group will have same chemical properties. Come on, quickly say, the element in a group will have same chemical property. Reason behind is what? The element in a group will have same chemical property. What is the reason behind it? The element in a group will have same chemical property. The reason behind is, I don't want to waste time. Sleep everyone, sleep. So the reason behind is only one, that is same electronic configuration, means the last electron, the valence electron remains the same group wise. Because of that only their chemical properties remain same. So big important points I am talking, please kindly pick these points, because you will have your offline test after a week, and continuous test I am going to conduct. That time I will not tell you that this class I taught this class I really am going to check your notes. So that time I am not going to listen anyone. Okay, Mativanan, good afternoon. Okay, Balram, that is Akshay, I guess, na? Good afternoon everyone. So now period wise I discussed one very important thing. In a period, same cell, same orbit will receive electron. Same orbit will receive electron in a period. Okay, so because of that we can talk about periodicity property in a period. Periodicity property means there are certain property. Oh Shivatsan, good afternoon beta. There are properties. From 11 you are having confidential examination. My all work kept pending because of COVID, because this week Saturday means today I had to conduct your offline examination. Question paper is also ready, but I am really angry because of COVID. I am unable to conduct your offline exam today and tomorrow, one maths exam, one science exam. So I am really what we prepare never comes true. Whatever God decides, that is only the true one. So I'm really angry. Only one work is there, and that too 1 week I cannot go out. I have to assemble everything from here now. So your PDFs are ready. So I have to work with PDF right now. Fine, I'm not going to talk about my preparation. I'm going to check your preparation. Okay, so now we are going to talk about characteristics in period. You know that 2n square rule is there. Okay, Kavya, don't worry about that examination. That examination is not the final examination. Okay, that examination is one of the examination. We are going to prepare well for that. I am there. I am now standing, means now I am ready. So now look here beta, 2n square rule is there. 2n square rule in a period means n is what? Cell. K, L, M, N shells. So different shells are there. Each cell will have a specific energy level. Okay, the energy level of a cell is fixed. So very important key points I am discussing right now. Please kindly note down. This PDF will be reaching you. In this PDF every information is there. But one important thing which extra shots I am talking to you right now, just note down somewhere. I am not going to ask you that you know that or not. Directly I will give question. That is, each and every shell of an atom, the energy level is different. Starting from K, L, M, N shell, this is called as going from lower energy level to higher energy level. That means if I am talking about K, means K is a lower energy level, N is a higher energy level. So till now, how many shells we can talk about? Total 7 shells we can talk about. Total 7 shells we are talking about, and each shell represent a period. Each shell represent a period. Each shell represent a period. So in the periodic table, if you will see the periodic table, so here we can see in this periodic table, that is total 7 periods are there. That means first shell having 2 electrons, second shell having 8 electrons, third shell having 18 electrons. Okay, now you will be saying, auntie, if I am counting 2 and 6, I am only getting 8. Then you have to remember one thing, there is a word called as penultimate and anti-penultimate. Exactly this scandium, titanium, vanadium, chromium, that belongs to 3D shell. That means it is exactly third third but presented in fourth. The periodic table alignment is in such a way that the third period total 10 element is in fourth one. Okay, because after fulfilling 2 electrons in the outermost orbit, we are exactly jumping inside the third orbit and filling the electrons, 10 electrons. Because of that, the third orbit 18 electron total capacity is there. Third orbit, how many capacity is there? How many electron capacity is there? The electron capacity of third orbit is 18. Then you will be saying that, aunty, in the third orbit only 8 electrons are there. Then third orbit total 18 electrons are there. Exactly the case in this was happened is that first orbit 2 electrons got filled, second orbit 8 electrons got filled. Now third orbit 8 electrons got filled, and after filling third orbit 8 electrons, then again we jumped to the fourth orbit filling 2 electrons. So this is K, this is L, this is M, and this is N. So what we did there is we shifted to nth shell and then we filled 2 electron. After filling 2 electron, we again jumped to M shell, that is the third period, and then we filled 10 electrons. But what we are doing here is, since the outer 2 electrons got arranged in the fourth orbit, so that's why this 10 electrons, scandium to that is cobalt, nickel, copper, zinc, scandium to zinc, we are exactly representing in fourth period. Are you understanding this point? These are very important points. Don't think auntie is dead, auntie is again alive, and I am started teaching the most important part in the periodic table. My still dream is to get the best score out of you. So please, you think 4 days vacation you got, now this vacation I am going to take out everything from you again. So get back to work first. So first orbit 2, second orbit 8, third orbit total capacity was 18. Third orbit total capacity was 18. So first 8 electron got filled, then jumped to nth cell, 2 electron filled, and again jumped to the third orbit, and there they have filled 10 electrons. So total 10 plus 8 will become 18. So that is the energy level. The energy level of the orbits keep on increasing on going from K, L, M, N. Quickly say understood or not. Quickly say understood or not. So energy level keeps on changing. Energy level keeps on changing. 2n square rule says that the energy started from the energy coming from lower energy level to first orbit lower energy level, second orbit higher energy level. So Kavya, I am just talking about, rather than thinking about coming examination, focus to what I am telling right now. I am just telling you period. So total how many periods are there? Now understand one thing, there are total 7 periods. Listen to my words first. Now focus in what I am teaching right now. I am going to discuss one more time. Everyone start focusing, because once I will start taking offline tests, that time I am not going to see who you are and what you have studied. Direct slap I am going to give. One incorrect answer will come. I am telling you, direct slap means I will be doing what I don't know. So for that time start preparing yourself. You have to face me in offline classes. After 1 week I'll start conducting offline classes, and that time regular tests will be there till your examination will not start. And regular test, regular offline, online, I'm going to create a very bad environment for you. So start preparing. P1, P2, P3, P4, I am promising you, I'll make your life hell. So total 7 periods will be there. Now K, L, M, N, they are exactly orbits. They are exactly orbit. How many orbits? Maximum how many orbits till now we can draw? So maximum total 7 orbits. 1, 2, 3, 4, 5, 6, 7. Each orbit 1 period. So first orbit 2 electrons means first period. Second orbit 8 electrons. Second period. Third orbit 18 electron according to 2n square. So orbit number 1, n equal to 1. So when orbit number 1, 2 electrons. So first period is having 2 electrons. Second period n will be equal to 2. So 2 into 2 square, 8 electrons. Third orbit n equal to 3. So when we are writing n equal to 3, 2 into 3 square, it is containing 18 electrons. How many electrons it is containing? It is containing 3 electrons. So sorry, 3 that is 3 orbit means it is taking, it has the capacity to 18 electrons. Fourth orbit n will be equal to 4. So 2 into 4 square, 4 4 16, 16 2 is 32. So next orbit is having a capacity to hold 32 electrons, and that is what we are telling, that we are moving from lower energy level to higher energy level. The orbit wise, the change in the orbit is exactly releasing energy level, lower energy level to higher energy level, lower energy level to higher energy level. So the more you will go away, it is called as higher energy level. Come on, quickly tell me, everyone understood lower energy level, higher energy level? So n can be totally 7. So 2 into 7 square. So till it is incomplete, till this orbit is incomplete, till this orbit is incomplete. Now I was talking about third and fourth orbit. I was talking about third and fourth orbit. Third orbit capacity is 18 electrons. Third orbit capacity is how many electrons? 18 electrons. Go back to the period and check. Third orbit, so this one is first orbit 2 electron, second orbit 8 electrons, third orbit 18. But here you see that third orbit or third period is having only 8 electrons. Third period, count 1 2 3 4 5 6 7 8. So only 8 is there, but we have promised 18. Then where is that 10 went? The 10 is here. The 10 is scandium, titanium, vanadium, chromium. This 10 is exactly in the fourth period. We can see that 10. It should be presented in third period, but it is actually filling in the third period. But in the periodic table, it is exactly written in the fourth period. Okay, it is in third orbit, written in fourth period. Third orbit, written in fourth period. I repeat, it is in third orbit but written in fourth period. So now I am going to show this one, how it is in third orbit written in fourth period. So first 2 electron filling over. Now second 8 electron filling is over. Now third orbit, first it will fill 8 electron. After filling third orbit 8 electron, it will jump to fourth orbit and it will fill only 2 electron, and after that it will go to penultimate cell to fill 10 electron. So exactly period number 4, 10 elements are there in deep transition elements. So these transition elements are exactly from third orbit. These are exactly from third orbit. It is exactly from which orbit? Third orbit, because 8 plus 10 will become 18. But in the periodic table, it is written where? In the periodic table, it is written in fourth period. Now understood? In the periodic table, good evening Sudarshan, in the periodic table it is written in fourth period. Remember this one, filling third orbit, written fourth period. Note down anywhere, because this is not, I have not written this in PDF, but this is the only fact. So if somebody will be telling you that scandium, titanium, vanadium, chromium, they are belong to which period? Quickly type and say, they are belonging to which period? Quickly type and say they are belonging to which period and they belong to which orbit. Quickly type and say they belong to which orbit and they are from which period. Orbit and period both I want to know. Scandium, titanium, vanadium, everything. Scandium, titanium, vanadium, chromium, they are exactly belonging to which period? Yes. Why are we filling fourth? Because of lower energy level to higher energy level. 4s is higher energy, lower energy level than 3d. Okay, 3d, 4s is lower. I told you the energy filling is from lower energy level to higher energy level. So fourth orbit alkali, that 2 we are filling now, their energy level is low. So once filling that 2 electron in the outermost orbit, we are moving towards a higher energy level. 3d means 3d. 3d is a higher energy level than 4s. And because of that, after filling there, so we are jumping inside. That's why it is called as penultimate cell, because one jumping you have done. So that's why it is called as penultimate cell. I don't want any mistake. If by mistake also they will give this question, you are not supposed to do mistake. I'm telling you clearly. Either you are studying in class 11th or studying in class 10th. This you keep in here. Orbit third orbit, you are filling 10 electrons, but where it is represented? It is represented in fourth period. Where it is represented? It is represented in fourth period. Yes, the energy, when you will be filling energy, lower energy to higher energy. Akshaya, your only focus will be lower energy to higher energy, and SPDF rule in that 4s is lower energy, 3d is higher energy, and because of that, beta, we are first fulfilling 4s orbital because it is having lower energy than 3d. Okay, 4s and 3d. So we will start energy as 0, 1, 2, sp, d and f. So if you are giving energy like this, you compare 4s. 4s means 4 plus 0, 4. 3d means what? 3d means 3 plus d is having 2, 5. So that means 3d is higher energy level than 4s. So that's why first we filled 4s orbital and then we shifted 3d and finished 10 electrons. Okay. Then we are shifting it back to filling 4 electrons, that is 10 electrons. So that's why beta, this is very specific point. I don't want any mistake. Whatever I am going to teach today, that is the most important part of periodic property. Periodicity I am going to teach. I don't want magic numbers I am going to teach. Diagonal characteristics I am going to teach. So today and tomorrow I am going to keep massive classes. Okay, because I got infected with COVID, so only I am not keeping offline class. Otherwise, so today it was in my card of offline. 3-hour offline examination was there today. Everything got shattered because of COVID. Now look here. Today, how much hour class I am going to take? It is none of that part. Most important thing is I have to finish my part today. So, I am not seeing I am having fever, cough, cold, I am able to stand or not. I am only seeing syllabus I have to finish and I have to teach my best today. So beta, just keep everything one side, study. I am only requesting you all, study and only study. Support auntie. Auntie needs to give you the best score. That is what the most important thing is. So now we have understood in the periodic table, that every time, not only one time, every time whenever we are filling d orbital, whenever we are filling this one, we are always jumping one step inside. We will always jump one step inside. So if this is presenting third orbit, then this one will be fourth. So this part is exactly representing, it is present in which period? Fifth period. But presenting which one? It is presenting fourth orbit. This one fifth orbit, but present where? Sixth. This one present which orbit? Seventh orbit. But here it is exactly present where? Sixth. Now you will be asking, auntie, what about lanthanide and actinide series, auntie? Lanthanide and actinides, why they are exactly actinide, this series they have kept down, and what is the reason behind? After 57 to 71 it is written like this. So I am going to tell you the entire story, not by SPDF, by orbit rule. So everyone pay attention here. I need to discuss an important point. Quickly beta, if you will not understand, don't think auntie is having COVID, this thing, that thing. You only think about, be selfish today. Till you will not understand, don't say auntie I have understood. I want this promise from you. Don't say that auntie I have understood. Say auntie I have not understood. Repeat one more time. Okay. So always keep on. Math today not there beta. Only because math tomorrow I am going to keep. I told you not keep what class is right now. Focus in that only. Okay. So now first period will be there. Period number 1. Sorry, orbit number 1. Now everyone pay attention, this very important story I am telling. Orbit number 2, orbit number 3, orbit number 4, orbit number 5, orbit number 6, Orbit number 7. So total 7 orbits, 7 periods. 7 orbits, 7 periods. 7 orbits, 7 periods. I am repeating again and again. In offline class, I want this to be in your tongue. I don't want, at that time I will not repeat. I will just ask you in the offline class, orbit means what? And then you have to say that each orbit is presenting a period. So first orbit 2 electrons are exactly filled. Second orbit 8 electrons are filled. Third orbit also first 8 electrons are filled. Then due to lower energy level, we went to 4s and filled 2 electrons. And then after filling 2 electrons, we jumped again into third orbit and filled 10 electrons in D subshell. Okay, how many in D orbital we have filled? 10 electrons. And then again we jumped out, and then in P we filled 8 electrons. After filling 8 electron, we again jumped out, and then here we filled 2 electrons. Again after filling 2 electrons, what we did, again we jumped, and then in D we filled 10 electrons. That means every time we are going out, filling 2 electrons, and after filling 2 electrons, jumping one step down. That is called as penultimate cell. I repeat, jumping one orbit down is called as penultimate cell. So you are jumping one step inside to fill the penultimate cell, and there you are filling 10 electrons. So when we are talking about periods, so total how many periods are there in the periodic table? 1, 2, 3, 4, 5, 6, 7 periods. So what we did, third period we filled 8 electrons, and then we went to fourth period, we filled 2 electrons, and then we jumped again to third period, and there this 10 electrons we have kept. We have exactly filled 10 electrons in third period, but since we jumped outer orbit, so in the periodic table atomic number wise elements are arranged. So in the periodic table, that 10 electrons that we have filled in the atoms, that is exactly presented in fourth period. That is scandium to zinc, it is present in fourth period, but filling of electron is in third orbit. Filling of electron started from third orbit, jumped to fourth period, fourth orbit, and then we jumped one step inside, filled 10 electrons. Then again we have filled another cells, and then we jumped. In the same way, for filling F orbital, one case came when we did one very big work, and that work is when we were in 6th. Now here this jumping work will be going for a massive change. This massive change is, first we went to 6s. Okay, in 6s we filled 2 electrons. 2 electrons we filled, and then we jumped to 5d, and we are supposed to fill here 10 electrons. As usual, because every time we are jumping to penultimate cell, and then anti-periods and orbits are same. Mustafa, I discussed about it beta, that periods are presenting orbits, but here the game of orbits are not constant, and that is according to 2n square. That is element capacity, means element having electron capacity will be 2n square. So that means what, each orbit 2n square. Mustafa, you see the video one more time, you will understand. 2, 8, 18, 32, 50, like that it will keep on increasing. That is lower energy level to higher energy level we are going, and there I have discussed everything. Just check the previous part of it. Now I am really in a very important situation. So now beta, we were supposed to fill 10 electrons here, but we are not filling 10. Here we are only filling 1 electron. After filling 1 electron, what we are doing is, we are doing a very big crime. We are jumping and we are going towards 4f. 4f. Here total 7 rooms are there. 1, 2, 3, 4, 5, 6, 7 rooms are there, and then we started filling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We filled 14. This is called as lanthanides. Lanthanides. Because the first electron filled is lanthanum, and this, in name of this total series is coming as lanthanides. Okay. Then again we filled everything. Then after fulfilling, we went to this and filled electron. Then we went to 7th orbit. In 7th orbit again we did same thing. First we filled 2 electrons in 7s, and then we jumped to 6th orbit. In there we were supposed to fill 6d, but total 10 electrons we were supposed to fill, but we didn't fill 6 total 10 electrons, only 1 electron we have filled, and then we jumped to 5f, and here in 5f first we filled total 14 electrons here, 1, 2, 3, 4, 5, 6, 7. So 14 electrons we filled, and after fulfilling this 14 electrons we jumped. So this type of collection, it is called as anti-penultimate cell. When you are jumping to outer orbit, from outer orbit how many steps you have went down? 1 and 2. So you are doing 2 orbits down, then it is called as anti-penultimate cell. Penultimate cell. So first one is penultimate, when you are only jumping 1 step in penultimate. When here for fulfilling f orbital, it is confusing, but it is very important. So you have to understand 2 things back to back. In the period, it is confusing, I know. First time you have to see the video one more time what I have said. So one small work I am going to do, that is 3rd period. 3rd, 4th, 5th, 6th, 7th. You went from 4th to 3rd, only 1 step, to fill 10 electrons in 3D orbital. How many electrons? So 1 step inside you went. After filling 4s2 electrons, you went 1 step in 3rd orbit. 3rd orbit to fill 10 electrons. So this is called as penultimate. Penultimate. Because you went only 1 step inside the orbit. Okay. But when you are in 6th orbit, and here you filled 2 electron, and then you went 1 step inside 5, you were supposed to fill 5d, you were supposed to fill 10 electrons, but you didn't fill 10 electrons. What you did? You only filled 1 electron, and that electron exactly filled. After filling 1 electron, the name of the element is lanthanum. But after that, rather than filling 10 electrons here, what you did? You jumped 1 step inside and you went in 4f for filling 14 electrons. So how many steps you went inside? How many steps you went inside? Thank you, Bittu, but I am not well, beta, right now. How many steps you went inside? You went 2 steps inside. So since you went 2 steps inside, beta, this will be called as anti-penultimate cell. This will be called as what? Anti-penultimate cell. Now understood, Kavya, when you are going only 1 step inside, so it is called as penultimate, but when you are going 2 steps inside, it will be called as anti-penultimate. Any confusing na beta? One more time. I told you today till not you will understand. I will keep on explaining this part. One time again you see the video, you will understand that I just kept on shifting and jumbling and going inside beta. My main content was keep on going inside the orbit. Okay, so now if I am going to draw this one, now look here beta, for first period 2 electrons filled, second period 8 electrons filled. बेटा कोविड हो गया था मुझे, अभी भी ठीक नहीं है, रिपोर्ट नहीं कराया अभी. So now here it is coming 8. Okay, so after filling 8, third orbit was supposed to fill 18 electrons, but what it did, it filled only 8 and jumped to 4s, fourth period. Okay, but rather than filling in fourth orbit, we jumped 1 step inside to fill scandium, titanium, vanadium. So this is representing third orbit, but this part is from third orbit but present with fourth period. third orbit present with fourth period, and then again we jumped to fourth orbit and filled this gallium 2, that is krypton, we finished that one. Okay, now again we jumped to fifth orbit. In fifth orbit we filled 2 electrons, and after that you see from yttrium, now again it is for fourth 4d, this is 4d, so this is representing fourth orbit. This D block is coming from fourth orbit but present in fifth period, present in fifth period. Now next what I am doing is I am again going in sixth period, but story changes in sixth period. What happened in sixth and seventh period? Anti-penultimate cells are there. What does anti-penultimate cells means, beta? Anti-penultimate cells means what? So here you have to start from 1, 2, 3, 4, 5, 6. So now in 6th and 7th, so what we were supposed to do? We were supposed to fill 6th orbit. So 6 2 electrons we have filled, 6s 2 electrons we have filled. After that we went one step down in 5d to fill 10 electrons. But are we actually fulfilling here 10 electrons? Come on, quickly tell me, beta. Are we filling here? Annie, tell me. Are we filling here 10 electrons or only 1 electron? Are we filling there 10 electrons or 1 electron? Tell me. Then you will understand this. Are we filling there? Usually what we used to do? Usually what we used to do? We used to fill 10 electrons. But here we are not filling 10 electrons. How many electrons we are filling? You have to tell me. 5d, how many electrons we are going to fill? Quickly say. (5d), how many electrons we are going to fill? 1 or 10? 1, absolutely, Annie. So now only 1, and after filling 1, beta, usually we used to fill total 10 electrons. Like the previous way we have done for third orbit, fourth orbit. What we have done in the previous case? First period only 2 electron was maximum capacity. Second period 8 electrons. Third period 18 electrons were there. So first what we did in third period, we filled 3s with 2 electrons and then 3p with 8 electrons. After that we shifted fourth orbit, and here in 4s we filled 2 electrons, and then we jumped inside again, and here 3d means 10 electrons we have filled, and then we went in fourth p period, and then here 6 electrons we have filled. Then we jumped again to fifth period, and fifth period we filled 2 electrons. Fifth period 5s, 2 electrons we filled, and then again jumped inside, and after jumping this time 4d, total 10 electrons filled. So like this 2 times we did like that. But when we went to 6th orbit, now 6th period, what happened? We filled 2 electrons. We were supposed to repeat the same story. That means jumping outermost orbit, filling 10 electrons, and then filling 2 electrons, again jump inside and fill 10 electrons. But here what happened? When we went to 6th orbit, so there we filled 2 electrons. Again same old story we had to repeat. We went to 5d to fill 10 electrons. But this time we are not doing this. We only filled 1 electron. We kept all the 9 place vacant, and then we jumped to 4f, and then here we filled 14 electrons. So since we back to back finished 1, 2, we went 2 cells inside, so that time it is called as anti-penultimate cells. That time it is anti-penultimate. That time it is called as anti-penultimate cell. That time it is called as anti-penultimate. So beta, for 6th period and 7th period only, where lanthanide and actinides are there, we are entering inside f orbital. We are entering inside f orbital. So only for 6th period and 7th period, you might have seen that 2 like this is down. You see, for sixth period only, you see from sixth period or seventh period only, you see here, that is, this is exactly lanthanide, and that is in name of lanthanide only, this total elements will be there. So that's why this is called as lanthanide, because first one electron get filled in d orbital, okay, and then other electrons are exactly filled in the 4f. Other electrons are filled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The other are exactly, so first one is filled in. So this first one is filled in. This one is filled in 5d1. And after that we jumped inside and we filled 4f1, 4f2, 4f3, 4f4, 4f5 till 4f14. Now I hope you might have understood that beta. These are for anti-penultimate cell. You shifted 2 steps inside, so it is exactly coming as anti-penultimate cell. Absolutely, Kavya, now you caught it correct. For 5th, 6th period and 7th period only, you can see here, that is 57 to 81 and 89 to 103. So beta, first this 2 na, it is exactly representing 3rd orbit. This is presenting 4th orbit. This is presenting 5th orbit present in 6th period. 5th orbit present in 6th period, but only one element entered into 5d. After that, remaining all element entered into f orbital. That's why beta, it should be presented like this, straight. 14 elements back to back should come like this, and after that again going back and filling the remaining orbitals. So see here, this is 5d2, 5d3, 5d4, 5d5. So what is exactly written here is this lanthanide series, the elements were supposed to be written, 14 elements were like this. So we took this one and we just aligned it like this, and we just aligned it like this. So that's why it is called as lanthanide series and actinide. Why? Because 5d1. So the valence electron is entering d orbital because of that, and after that it is jumping inside and filling 14 electrons in the subcells, F subcell. So that's why beta, the series name went for lanthanide. Here the last one is entering 6s1, 6d1, and d1 is actinium. In name of actinium, actinide series. In name of actinium, actinide series. Tanishka, what is the doubt beta? Tanishka, in full form, SPDF. Yes beta, SPDF, that is spin fundamental, D is exactly discrete like that, it is there beta. Spin fundamental discrete like that, it is there. P is primary like that. So lanthanide and actinide series are anti-penultimate cell. Akshaya, one chocolate for you. This is exactly, so lanthanide and actinides are exactly anti-penultimate cell, and these are penultimate. 3D, 4D, 5D, 6D, they are penultimate, but since lanthaniums to actiniums, they are exactly good, throwing the element inside, so that's why they are exactly anti-penultimate cells. I rest my case. Do watch this video one more time if you really want. I told you the basic lifeline of this question. So lanthanium, actinium, a very important point I have discussed. So after, don't have confusion that once it went, I'm not going to discuss about this, I'm going to talk about this. So first it went 6s, 2 electrons filled, and then it went 5d, and then filled only 1 electron, left all chambers empty, and then it went 4f, so to fill 14 electrons. After filling 14 electrons, then it is jumping again and then filling the remaining 9, and that's why in the periodic table, beta, you can see that first lanthanium, this 57 means filling 1 d orbital and then going in 14 and then fulfilling it. I rest my case. Understood this point? Shall I leave this section now? Next time in the periodic table, if you will be seeing this one, say that it is anti-penultimate cell. It is 4f orbital and this is 5f orbital. That means staying in 6th period. Staying in which period? 6th period. We went one time to 5d and then we went to 4f. One time to 5d and then we went to 4f. to fill 2 times. So 2 times we are jumping inside the orbit. That's why this will be anti-penultimate cell. This will be coming under anti-penultimate. Every time beta it will be exactly, Tanishka, the anti in the times if goes and goes beta, it will go 2 times backward. Means you might have seen that for penultimate na beta it will go 1 time inside. For anti penultimate you might have seen that it is going 2 times inside. You see Tanishka, in anti penultimate it is going 2 times inside. For anti-penultimate it is going how many times inside? You see 6 to 1 orbits 5 and then it is going to 4. So 4th orbit, 5th orbit, 6th orbit. For 6th orbit it is going 2 times inside for lanthanide. Okay, same story repeats for 7s. So first it is going to fill 2 electrons in 7s. Then it is going to go to 6d for actinium. 1 electron filled and then it will go to 5f for fulfilling 14 electrons. For fulfilling 14 electrons. I hope I have told the point now. We have more works to discuss in the periodic table. Many things are there I have to discuss. So in the periodic table, now we are going to go towards characteristics, merits of modern periodic table. So what and all are the, good evening Rohit. So what and all are the merits of modern periodic table? First, modern periodic table is exactly easy to remember and reproduce. So we can exactly represent this modern periodic table easily. So it can be presented, presented very nicely. Next important thing is, so we know that group wise, since the electronic configuration, same electronic configuration, valence cells will be same, means valence electrons will be exactly same in each group. That's why they have similar chemical properties. Okay. Next is, it relates position of element in the table by electronic configuration. Yes, by electronic configuration, SPDF we can say, or KLMN, we can be able to identify the last electron filling in the orbital. So that part is, it's relating very easily. So we can say position can be related easily with the help of modern periodic table. Satisfactory position is given. See, cobalt and nickel, where the one which has not given a satisfactory position in Mandalic periodic table, but in modern periodic table they are exactly coming in heavy metal position. That is a very satisfactory position given to them. Next important point is yes, 6th period anti-penultimate. So again in the same story for 7th, means for actinide also 7 to 6 and then 6 to 5. So 5f orbital is getting filled. 5f, 14 electrons are getting filled there, Kavya. Okay. Now next is position of isotopes varies in modern periodic table. So now how can we say, where is the isotopes kept in the modern periodic table? Can anybody tell me where is the isotopes kept in modern periodic table? Then you will be saying that since auntie, in the periodic table the elements are presented according to their atomic number. So in the periodic table we are writing the atomic number of the element also and atomic mass also. So it is very easy to keep the isotopes together with the element. Yes, whatever isotopes are there, the isotopes are present with the same element in the periodic, means the location of the isotopes are same. The location of the isotopes are same, and that is the element itself. Means whatever elements are there, since it is presented by their atomic number, so all the isotopes can be placed in the same atomic number element. Okay, like hydrogen, deuterium, tritium and protium are there. So it is present in 1s1 only. Along with the element we can relate the isotopes with that element only, because here the electronic configuration is based on atomic number. So only. So there is no default part in the presentation. Okay. Penultimate cell, correct only beta. And that green color what you are seeing, that is coming under anti-penultimate cells. Absolutely Akshaya. So atomic number increases in regular manner on going from element, so it becomes easy to predict number by between 2. So I already told you in the previous class, I discussed a very important point in the previous class, that why atomic mass has more default than atomic number, because atomic number are discrete whole numbers. So there is no possibility of of keeping any decimal number between them, because discrete means whole numbers only can come. So atomic number starts with 1, 2, 3, 4, and that is hydrogen, helium, lithium, beryllium, boron. So there is no room in between left to discover one more element and keep inside it. So that is no possibility. So that's why it is again a very plus point. Okay. Now next important thing here is there are very important points to discuss about. So 4 important points, and these 2 important points are coming in examination. These 2 10th and 11th, these 2 points are very important, and these 2 points are coming in board examination. So please kindly pay attention for these 2 points. I am going to discuss these 2 points now only. Okay. So now what is this is the period number of an element is equal to number of cells in the atom. We discussed now the period. How many periods are there? 7 periods. How many orbits are there? 7 orbits. Understood this point or not? So that's why I discussed from the beginning section only. Period number of an element is equal to number of cells in an atom. Number of cells in its atom. So period number is representing the number of cells. How many number of cells are present in the atom? That will be equal to period number. That will be equal to period number. How many shells are there? That will be equal to period number. This we have already discussed. This we have already discussed here. I told you now that how many? 1, 2, 3, 4. So total 4 cells are there. N equal to 1, N equal to 2, N equal to 3, N equal to 4. So 4th orbit 2 electrons are getting filled, and then jumping to 3D orbit and filling 10 electrons. So whatever activities are taking place, it is taking place inside the atom. Okay, but where, how many cells are present here? Total 4 cells are there. So since 4 cells are involved, so its period number is 4. So number of cells will be equal to its period number. So period number will also be 4. So total 4 periods, 4 cells. So here also beta, so the electrons are going inside filling, that is a different case. But outer orbit, how many orbits are exactly used, that many period will be there. In next class also now we did this thing. In next class also we did like that. We said that first we are filling 1, 2, 3, 4, 5, 6, 7. So now we filled first 6th orbit, 2 electrons we filled, 2 electrons we filled, and then we went to 5D, filled 1 electron, and then we went to 4F. So now total how many orbits we have used? 1, 2, 3, 4, 5, 6. So since 6 orbits we have used, so its period number is 6. 6 orbits we have finally used, so its period number is 6. This is a very important point to remember, and that's why I have discussed this important point. These points I have taken from outside book, not from your book. Okay, the period number of an element is equal to number of shells in its atom. So this PDF you keep with you, it will be very helpful. So if 2 or more elements have the same valence shell, then they belongs to same period of the periodic table. Yes, they are belonging to same valence cells are there. That means sodium and magnesium. Sodium and magnesium, in both the cases, the electrons are filled in the same orbit. The electrons are filled in the same orbit, so its period number will also be same. Let's check this one out. Sodium and magnesium. Now sodium and magnesium period number is same. How sodium and magnesium period number is same? Sodium atomic number is 281. Magnesium atomic number is 282. So the last electron filled is 3rd orbit. 3rd orbit. Here also the last electron filled is 3rd orbit. So since orbit number is same, so that's why period number is 3 here. Shall we check the period number of sodium and magnesium now? Shall we check the period number of sodium and magnesium? You see the period number of sodium and magnesium is same. Sodium, magnesium, same period. Then you see potassium, calcium, same period. Here also d orbital, all the electrons are filled. So that is exactly going to represent the same period, 4th period. Okay. I hope you might have understood this point. So the next important point I am going to discuss is the group number of an element having up to 2 valence electron is equal to number of valence electron. Now after that, whatever will be there, it will be added with 10, and they will be only presenting for representative elements. Everyone, Keep your brain free from 1 minute to understand this point. Keep your brain free to understand this point. Everyone first tell ready, then only I'll discuss. Get ready. Get ready to discuss this point. And this is a very important point, and this question comes in CBSE. So it is my duty to let your brain first free. Ready everyone? Once you will be ready, then only say auntie ready, and now you can discuss this point. First tell me, are you all ready to listen to this point? If you are ready, then only I'll start. How many are present right now? Are you ready? Then only I'm going to discuss this point, beta. Ready everyone? I cannot stand more, yaar. Come on, you can say yes or no. Typing yes or no will not take more time, beta. Yes, Kavya, because this point is very, very important. It is coming. Now they will give you an element. Okay. They will give you the element and they will give you the atomic number of that element. And they will tell you it belongs to which group. Understood? They will give you an element and they will give you the element atomic number. And they will ask you it belongs to which group. Then I'll tell you one small shortcut method here. Okay. Now what is the shortcut method here? If the valency of that element is +1 and +2, then directly you say if valency is +1. If valency is +1, then say group 1. If valency is +2, means outermost orbit 2 electrons are there, then you say group 2. Okay, outermost orbit 2 electrons are there, then you say group 2. But when atomic number like all this are given, then 10 is added. Then 10 is added. Can I show you one simple example? Now see, boron, carbon, nitrogen, oxygen, fluorine and neon. Boron valency is +3, means outermost orbit 3 electrons, outermost orbit 4 electrons, outermost orbit 5 electrons, 6 electrons, 7 electrons, 8 electrons. Fine. Outermost orbit, how many electrons are there? So when you will see that the valency is exceeding 2, means outermost orbit more than 2 electrons are there, then add 10. Then group number 13. Group number 14, group number 15, group number 16, group number 17, group number 18. Now check, is it there or not? Is it there or not? See, boron, group number 13. Valency means outermost orbit, how many electrons are there? What is the valency of boron? So hydrogen, helium, lithium, beryllium, boron. So boron is 2 and 3. So last orbit, how many electrons are there? 3. 3 plus 10, 13. Carbon, outermost orbit 4 electrons. So 4 plus 10, 14. Outermost orbit 5 electrons. So 5 plus 10 will become 15. So nitrogen, now here 2, 6. 6 plus 10, so group number 16. In the same way, when we will check for aluminium also, outermost orbit 3 will be there. So 3 plus 10, it will become 13. Gallium also, outermost orbit, what will be the valency? 3. So 3 plus 10, 13. So group number 13. Outermost orbit here, by seeing the element, whatever is the valence electron, means the outermost orbit, only there what you have to do, you have to add 10. What you have to add there, you have to add 10, and that will become the group number. Quickly tell me, you understood this point? This is only possible for representative elements. Representative elements means S block and p block are called as representative elements. This is representative element and this is exactly representative elements. So here you don't have to add 10. For S block you don't have to add 10. For valency 1 and 2 it will become the group number. So outermost orbit 1 electron means it is group 1. Outermost orbit 2 electron means group 2. Outermost orbit 3 electron means 3 plus 10, 13. So group 13. Outermost orbit 7 electron means 7 plus 10, 17. Outermost orbit 7 electron means 7 plus 10, 17. That means group number 17. Maximum they will ask till here, argon. Maximum they will ask till argon. Okay, I hope you might have understood this one. Come on, quickly tell me, did you understood this point? And this is a very important point here. This is a very important point I discussed right now. S and P only, that is representative elements only. Only for representative elements this part is going to be true. So that's the important point I have written, important point, that is it is only, that's why this PDF, once you will receive this PDF, that's why I have written that it is only possible for representative. If 2 or more element have same number of valence electron, then they belong to same group of the periodic table, and that is what it is only presenting for representative element. S block and P block are called as representative elements. I repeat, S block and P blocks are called as representative element. For S block you don't have to add 10, only for P block. Everyone come on, tell me one thing. If the outermost orbit is having 6 electrons, so what is the group number? If the outermost orbit have 6 electrons, then what is the group number? Come on, quickly tell me. If the outermost orbit have 6 electrons, then what is the group number? If the outermost orbit have 6 electrons, then what is the group number? Absolutely correct, Kavya Akshaya. So outermost orbit is having 4 electrons. Outermost orbit is having 4 electrons. Very good, Kardiga. Dharni, absolutely correct. Kamya, absolutely correct. Now outermost orbit is having 4 electrons. If outermost orbit is having 4 electrons, then what is the group number? Which group number we are talking about? 14. Absolutely correct, Dharni. So it is going to be group number 14, and this is a very important point. CBSE again and again they ask. They will ask this question in case studies. You know, they will make a case study and they will ask this question. So 14 is the correct one. Group number 14 is the correct answer. Now we are going to understand in next class. Tomorrow I am going to keep another special class for you, and that is for periodicity. So we are going to talk about periodicity of an element. So periodicity of an element, there we are going to understand shielding effect, screening effect, effective nuclear charge. All these important points we are going to discuss tomorrow. Representative elements, S and P are together called as representative elements. S and P together are called as beta representative elements. S and P together, please one more time recall these points tomorrow before the class. I want everyone to remember these sections. Okay, remember this point. Remember this whatever I taught today, so that I will go towards the next important point in the periodic table. Fine. Okay, don't thank me because I really want you all to be the best right now. Okay, beta. So maths class is not there, but tomorrow I am going to conduct maths class. Tomorrow my plan is to finish median and mode, and to finish your syllabus in maths. Construction video today I am going to make and release, beta. So I am having extensive work right now. Okay, bye everyone.